Good morning, students. In last class, already we are discussed about terrestrial magnetism concepts. Okay, terrestrial magnetism is nothing but we are not discussed as the branch of science which deals about Earth's magnetism only. We are calling as a terrestrial magnetism. So now, after completion of this terrestrial magnetism, so few new more topics I am discussing here. Those are magnetizations and magnetic intensities. Okay, what is the thing? Magnetizations and magnetic intensities we are discussing. So and then in this class, I am ready to discussing about magnetizing force. Next, one more thing is the intensity of magnetization. Then one more thing is magnetic susceptibility. Next one more is magnetic permeability. Next, relative permeability. And finally we will get one relation between susceptibility and relative permeability. Those things in this class I want to discuss with you. First of all, in this one, okay, first new statement is intensity of magnetizing field, or this one is also called as magnetizing force. What is the thing, students? Intensity of magnetizing field or magnetizing force, this one is represented as a capital H. With capital H we can represent it. One thing, students, if you are taking any magnetic substance, maybe such as iron, cobalt or nickel, if you are kept that magnetizing material into any magnetic fields, after sometimes those materials are also okay acquires some magnetic nature. Is it clear or not? This is in introduction class only we are discussing. So here for that field some strength is requiring for converting the given magnetic substances as a magnet. Those strength of that fields only we are calling here as magnetizing forces. So that is we are calling as capital H also. See here how we are representing the statement means, observe carefully. The strength of the field due to actual current to magnetize a material placed in the field is called, we are calling as magnetizing force. What is the statement, students? The strength of field due to actual current to magnetize a material placed in magnetic field is called magnetizing force. So numerically how we can represent that one means, that is we are representing here as the ratio of magnetic conduction to the permeability. What is the general thing mathematically? Okay, that is magnetizing force is nothing but the ratio of magnetic conduction to the permeability. So in air medium how we can represent means, that is H is equal to B naught by mu naught. Okay, students, H value is equal to, how we will represent, students? H is equal to B naught by mu naught. We will represent it here, and then here B naught is also we can taken here as H into mu naught, where mu naught is we are calling as permeability of a free space or permeability of a air medium. Is it clear, students? If you are going for other than air medium, means if any other particular medium we are taken, means that in that condition H value is equal to, we will taken as B by mu. What is the thing here? H is equal to B by mu we will represent here, students. Therefore B is equal to, we can able to write as H into mu. Is it clear? Okay, students, here what is mu here? Permeability of a given medium. Okay, like this we will get a few conditions. See, students, then further we are going for units for this magnetizing force or intensity of magnetizing field. See, SI unit now I am showing to you. In numerator, actually capital B is present. See, that is nothing but magnetic conduction. So for that one we know one thing, Weber per meter square, one unit is there, and one more thing is nothing but Tesla also. So here I am writing Weber per meter square divided by, already we know previously for permeability we have one formula, that is nothing but Henry per meter. What is the thing, students? Henry per meter is the unit for this permeability. So finally, on simplification, intensity of magnetizing field or magnetizing force having one unit, that is ampere per meter. What is the unit for that? In SI system, ampere per meter is the SI unit for which one? Capital H. So we will get a dimensional formula as A by L, or nothing but A into L power minus 1, or A L inverse is there represented as okay, what's the thing here? Dimensional formula for here capital H. Okay students. So one more thing students, now this is a new statement for you people. Intensity of magnetization. What is intensity of magnetization means, for any magnet compulsory we have magnetic moment, and for a given magnet volume is also present. So by taking the ratio between magnetic moment and its volume, that only we are calling as intensity of magnetization. So this intensity of magnetization will be represented with capital I. I value is equal to capital M by V. We will represent. So once go through here statement. The magnetic moment per unit volume of a substance is called as intensity of magnetization. Main formula is I is equal to M by V. This is equivalent to M into 2L. This is nothing but okay, pole strength into length of the magnet. Length of the magnet, how I am represented here? 2L I am represented here. Okay, in denominator volume I am taken as area into length of the magnet. Here 2L is nothing but length of the magnet only. In numerator and denominator 2L will be cancelled, means we can able to write here pole strength per area of the magnet. Okay, what is the thing students? Pole strength per okay area of the magnet we will represent here, and then we are discussing about a few things. Okay, those are nothing but here units. Units means pole strength we have unit ampere per meter, and in for area meter square. Finally on simplification we will get ampere per meter is a unit for capital I, or intensity of magnetization. So here also we will get a dimensional formula as A by L, or A L inverse. So here clearly mentioned students, ampere meter square is capital M units, meter cube is for volume. So finally on simplification we are getting here as ampere per meter, or ampere meter inverse. Okay, dimensional formula is ampere L power minus 1, or A L power minus 1 is we can representing. So after completion of that, just we will discuss about magnetic susceptibility. Magnetic susceptibility is represented with Xi. Okay, actually students, this is a unitless and dimensionless quantity. So before going to that one, so just I am representing few things. We know already intensity of magnetization I and intensity of magnetizing field H. By taking the ratio between intensity of magnetization and intensity of magnetizing field, that value only we are taken as okay magnetic susceptibility. So this magnetic susceptibility is a unitless and dimensionless quantity. So just here I am ready to discussing here that statement. The ratio of magnitude of intensity of magnetization to that of magnetizing field is called magnetic susceptibility. So Xi is equal to I by H. So intensity of magnetization divided by magnetizing field. So this is a unitless and dimensionless quantity. Why reason is for I ampere per meter is a unit, and for H also ampere per meter is present. Both are having same units. So ultimately both will be cancelled. So we are unable to get any units, and also we are unable to get any dimensional formula. So finally we are decided to here this susceptibility or magnetic susceptibility are having no units and no dimensions. So after completion of this one, we will discuss about magnetic permeability, that too in terms of magnetic inductions and intensity of magnetizing forces. Okay, so in that words, by using those words only, just I am recalling the statement for magnetic permeability. Okay students, the magnetic permeability statement how we will represent means, the ratio of magnitude of two ratio of total field inside the material to the top intensity of magnetizing field is called magnetic permeability. The ratio of magnitude of a total field inside the material to the top intensity of magnetizing field is called magnetic permeability. So here magnetic permeability in general, mu is equal to B by H, we will represent, therefore here B values becomes as mu H. Okay students, so if you are going for units means Tesla per ampere per meter, we will get finally this unities were taken as Henry per meter. What is the thing students? Henry per meter we will represent. So this one dimensional formula here represented as mLt power minus 2 a power minus 2. This is the dimensional formula for magnetic permeability. So after completion of magnetic permeability students, just I want to discuss about relative permeability. So we know how many types of permeabilities we have. One is permeability generally in case of air medium, and another one is any other medium. For air medium, that is we are represented as mu naught, and for any other medium, that is we are taken as mu only. So magnetic permeabilities concepts completed means just we are going to relative permeability. So once observe this relative permeability statement, the ratio of permeability of a medium to the top free space is called relative permeability. Just nothing but mu r value is equal to mu divided by mu naught, or one more thing, this is also represented as B divided by B naught also. How we will represent students? Mu r is equal to mu by mu naught, that is equivalent to B divided by B naught also we will represent it. So students, this is also a unitless and dimensionless quantity only. Why reason is here this is also permeability of medium, this is also permeability of free space or air medium. So both are having same type of units, nothing but Henry per meter. So both will be cancelled, and finally we will get there is no units and dimensions for relative permeability. Students, finally we want to discuss about few relations here. Those are nothing but relation between B, H and I. So here how that B and H I are interrelated means B value is equal to mu naught into H plus I, we can able to write. What is the relation here? B value is equal to mu naught into H plus I, we can able to write. Then on simplifications, B by mu naught is equal to H plus I, one notation we will get. Therefore H value is equal to B by mu naught minus I. In these three ways we can able to represent the relation between B, H and I. So finally students, I want to get one relation between relative permeability and susceptibility. Relative permeability and susceptibility I want to discuss with you. So how I will discuss here means, we know just now the thing B value is equal to mu naught into H plus I. So B value is equal to mu naught, here H by taking common means mu naught H into 1 plus I by H we will represent. Just I am cross multiplication H here, therefore B by H is equal to mu naught into 1 plus I divided by H. Just now we are discussing students here by statement for permeability mu is equal to B by H we know. So therefore instead of B by H I am represented here mu is equal to mu naught into 1 plus, instead of I by H I am taken here as magnetic susceptibility. By reason is I by H is nothing but susceptibility only. So B here mu is equal to mu naught into 1 plus I we are finding. So therefore mu by mu naught is equal to 1 plus I. So just now in this session only we are discussed about relative permeability. Relative permeability is nothing but mu by mu naught, therefore mu r is equal to 1 plus I. So these are the relations. Mu r is equal to 1 plus I. So these are the things we are completed students. In next class, based on these formulas I am able to solve few problems for you. Okay students, thank you.